going to move to our main keynote from our gold sponsor, from CACI. Yes, we've got this thing here in the front row. I would love to introduce you to Nick Barnes. Nick is a senior technical consultant, and he's going to be talking about something called space weather. He's been working with the Met Office to improve the UK's capabilities for space weather monitoring and prediction. I had no idea that space weather was a thing. Nick, come on. Let's give him a round of applause.
My name's Nick Barnes. I work for CACI. I'm here to talk to you about our space weather project and how we've used tech to improve our research to operations capability. Let's get going. So CACI, if you're not too aware of us, we're a professional software and technology consultancy. We work across a wide range of domains, including things like national security and intelligence, defense, law enforcement and borders, and of course, critical national infrastructure. That's where we've worked with the Met Office now really successfully for many years, and the space weather project specifically, we've been delivering for about 7 years. As you mentioned, I expect most of you are probably aware of who the Met Office are, why they're so important. Space weather, perhaps less so. So a bit of history there is that it was added to the UK National Risk Register back in 2011. That was given to the Met Office to own and mitigate, and in response, they set up the MOSWOC. That's the Met Office Space Weather Operations Centre, and that's what you can see a picture of on the screen behind me. So this is one of only 3 continuously manned space weather capabilities in the entire world, the other 2 both in North America. And at CACI, we're responsible for the entire software system to deliver that capability. Sorry. So the capability itself allows people like the one you can see in the picture there to deliver forecasts, alerts, warnings, general situational awareness across a wide range of industry, directly to government. There's a public website and a Twitter feed, so if there's public interest, you can see it there. And also to some partners we've got all around the world, like the European Space Agency. So when I speak about space weather itself and these alerts and warnings, what I'm really referring to are expulsions of matter and energy from the sun, which fly through space and then potentially interact with our planet, an impact on our technology, our infrastructure, and of course that eventually impacts on our lives. One of the really interesting things about space weather is that the more you hear about it, the breadth of these attacks you start to understand. I've got 4 examples up on the screen I'll talk about in a minute, but the potential impact is unbelievably vast, and also the size of them, right? Because space weather events sometimes can affect the entire sunlit side of the Earth at once, so the scale of these things can be absolutely vast. So if we look at my 4 examples there, one of them is aircraft, so we deliver alerts to aircraft all over the world. In response to one of our alerts that a space weather event's ongoing, an aircraft might want to change its flight route, it might want to change its altitude, or even land completely during an extreme event. A more minor event, they might just be interested that the instruments they rely on aren't quite as effective as they always are, and take appropriate action. We've got communication, so my 2 pictures of the ships there represent over-the-horizon communication. This can be hugely degraded by space weather. So in response to our situational awareness, a ship might want to do something like change its communication method, perhaps try on another frequency. And if that doesn't work, it can just be really important information to know that that degradation in signal, that communication quality, is of natural origin. That can be really important in some situations. Next, we've got my little city graphic, so that's meant to represent us, our energy, our power grid. I suspect a couple of the guys on the previous talk will know more, but we deliver alerts and warnings to energy companies, and in response, they might want to shut off bits of the grid, activate some transformers or circuit breakers to help dissipate the charge induced in our grid by space weather. So a good example here is that in the province of Quebec in Canada a few years ago, a space weather event caused a 9-hour complete blackout across the entire province, so that's a pretty huge impact. Finally, we've got satellites. So of course, the higher up you go, the less protection you get from our atmosphere, which is why planes are badly affected, but satellites are obviously even higher up, so they get almost no protection at all. They also have very sensitive instruments on them, which can be damaged by space weather. So a satellite operator who we deliver alerts and warnings to might want to reorientate their satellite to help protect some of the instruments, or just switch them off entirely. So an example here is GPS. During a space weather event, that can be tens of meters out, it can be hundreds of meters out, and for you or I, heading to work or whatever, I mean, it's a pain, but it's not the end of the world, right? You can imagine maybe if there was a natural disaster, though, and some kind of rescue operation. That information could be absolutely crucial to saving people's lives. So the rest of my time, I want to chat to you about the actual software system we develop. You can largely break it down into 3 areas. So we have a data ingestion bit, we have a processing bit, and then we have a visualization bit. So that's where we take the output of the first 2 steps and we show it to our expert users, hopefully in a useful way. It's that middle stage, the processing one, I want to concentrate on. One of the things we do there is run very complex scientific models. And what my graphic there is meant to represent, these models, they're not all developed in-house at the Met Office. They're developed by academics and researchers and organizations all over the world. And then one of our jobs at CACI is to get them running operationally in our space weather system. So that's the bit in the middle. Now, that word operational has quite different meanings. When the coding is complete on these models, it's considered operational by the people who developed it. Like you feed the right data in, it chugs away for a bit, you get some hopefully useful output out, which is scientifically valid. It's operational. But for us and the Met Office and probably a lot of your organizations, when we think about operational software, we think about things like, does it have security embedded in it? Does it have, is it receiving its data from a known good and safe source? Is it integrated with our support team? So if something goes wrong at 2 in the morning, I'm definitely not going to be getting that call. We need a support team who can see what's happened, know how to diagnose it, know how to fix it, or maybe even the thing can fix itself. That is the research to operations process. So it's us bolting all these services on after the fact, once we've been sent this model, and sometimes it can literally be a zip containing hundreds of thousands of lines of code. We have to bolt all this stuff on. Then we have to find somewhere to run it. Some of them could take a couple of minutes on your laptop at home. They're pretty simple. Some take hours on the Met Office supercomputer. So there's a big infrastructure concern there as well. Real problem is, once we've done all this and changed the model, got it somewhere to run so it can deliver value to our forecasters and help keep us safe, the poor scientists and academics then have to validate the whole thing all over again because of the changes that have been made. So to try and help this problem, a couple of years ago, in a rare moment of clarity, our government decided to put up about £20 million of space weather funding. So the majority of this went out to organizations to develop new space weather models, but some of it came to us at CACI, and we've been working closely with the Met Office since to develop a research to operations infrastructure. So that's some kind of platform to ease this process of getting these models into operations. Now, when we approached this problem, we did a discovery first, and we really wanted to understand how the developers make these things. We were very clear we didn't want to steam in and sort of say, what have you heard about Agile, and just read this awesome Spotify blog I found, and if you could just completely change the way you work in a couple of months, that would be brilliant. It's normally not a great route to go down. These are very intelligent people who've been working successfully for a long time. So we wanted to use tech to kind of silently improve this process and let them go about their day jobs in the way they always have. So we broke the development process down into 4 stages. There's a create stage, so that's where they're doing their coding. There's a build stage, so we turn that code into an artifact, something we can run. There's a deploy stage, so we find somewhere for it to run. And then a verify stage. Is it producing valid scientific output? Is that valuable, etc.? What we did is, part of the discovery, we realized that these academics, these organizations, they're experts at creating the models and verifying them. CACI, we're very good at developing software and deploying software into the cloud. So we used our technology to enable this process, and we took care of the build and deploy steps you can see up there, and let the model developers concentrate on what they're good at. That's creating the things and verifying the output. I do have some AWS pictures up there. You might be relieved to know I don't have time to go through them all, but I can. They're very interesting, honestly. I can talk you through the process for these academics now as they're using the system. So what they do is they code their models at home, at their institutions, whatever they want, as they always have done. That came out of Discovery. It was really important. That's how they wanted to work. So they code their models at home. They push their code up to cloud source control. That triggers our build pipeline, which we've developed, so they don't really know that much about it, but it's a malleable pipeline in the public cloud, and it takes their code, and it takes a bit of config, and puts them together, and turns that model into a Docker image, which is like a small virtual machine, if you haven't come across Docker before. Every organization using this system gets its own private Docker registry. Again, from the discovery, they like to download and they like to run their models on their local laptops, so they're still able to do that if it's appropriate. But crucially for us and the Met Office, that build stage finishing triggers the deployment stage. That creates an exact replica of the Met Office operational system in the cloud. It's private to every organization who runs it, and that, from us, has things like the security built in from the start. There's an API there, which is serving them the data their model needs from sources we've vetted to be clean and good and safe. There's the integration I mentioned with the support teams from day one, which they can use. There's all these different things. There's a scheduler in there, so it runs on time, every time when we need it to, et cetera, et cetera. I won't go through them all, but it's there. And remember, all the developers had to do is push up a single commit, and a few minutes later, they have a replica of our operational infrastructure running their model. The verify stage, we help them out with as well. So some of these models can chuck out hundreds of gigabytes, terabytes of information. Sharing that with people is obviously a challenge, so we have cloud storage there. There's an API sat on the front. They can hit the API, get a link back, which has some security embedded in it, credentials, and then share that with whoever needs to come back and verify the model. When it finally comes time to put this thing into operations, we simply point that deploy stage at our operational account in the cloud rather than this development one, and it's away, it's in operations, it's providing output to the forecasters and helping to keep us all safe. That's pretty much the end. You'll see I'm not hugely into social media, but my email address is there. If you're interested in space weather, that is space weather the thing, space weather the project, or just how it might affect your organizations, please do send me an email. I'm very friendly, or just come and chat with me in the bar afterwards. Thank you very much.
Thank you very much.